Let's discuss another important spectra, spectrum number 18. So look at the IR mass spectrum of this compound. Molecular formula is given. So first of all, let's find out hydrogen deficiency index, HDI, or degree of unsaturation. Formula is 2C plus 2 plus number of nitrogen atom minus hydrogen minus halogen divided by 2. So simply put the value 2 remain as it is. Number of carbon 3 plus 2 plus number of nitrogen in this compound 0, hydrogen 6, halogen 1, chlorine 1, bromine 2, halogen divided by 2. So 3 times 2, 6, 6 plus 2, 8, 8 minus 8 divided by 2 is equal to 0. So degree of unsaturation of this compound is again 0. If you look at the IR spectrum of this compound, the IR spectrum is telling us that there is only sp3ch stretch present in this compound. sp3ch stretch. While carbon bromine and carbon chlorine signal is also shown in the IR spectrum of this compound. So CBr stretch, CCl stretch is also present in this compound. Again, if you look at the mass spectrum, I told you whenever chlorine or bromine is present, you will get M plus 2 peak, M plus 2 peak. Okay, now degree of unsaturation 0, sp3ch stretch is present in this compound. So now let's move towards the carbon 13 NMR spectrum of this compound. So proton, the decoupled spectrum is given in this compound. We are getting how many signal? 1, 2, 3. 3 signals. CH2, CH2, CH2. It's showing might be a 3 CH2 is present in this compound. So let's see whether 3 CH2 or 2 CH2 are present in this compound. If you look at the proton and the, so basically the information provided by carbon 13, there are 3 different types of carbon are present in this compound, and each carbon is connected with 2 hydrogen, CH2, CH2, CH2. So we have 6 hydrogens, so total 2, 2, 2. So same information will be provided by the IR spectrum of this compound. Sorry, NMR spectrum of this compound. First of all, let's see the molecular formula C3H6. Let me write the molecular formula again. Molecular formula is C3H6BrCl. Okay, this is the molecular formula. This is a 2 proton signal. This is also a 2 proton signal, and this is also a 2 proton signal. Integration is same. This area, and this area is same. So it means this compound is giving us 3 signals. 2 signal, 2 proton, 2 proton, and 2 proton. And their expansion is also shown. Expansion is also shown. For example, the expansion of this signal is shown over here. It looks like 1, 2, 3, 4, 5. It looks like a pentate. So it means we are getting a 2 proton pentate. So we are getting a 2 proton pentate in the range of 2.4 ppm. Okay, if you look at the second one, which is appearing 3.5, we are getting a triplet and triplet. Okay, so 2 proton triplet and 2 proton triplet. So how we will draw a structure of this compound? 2 proton, how we can draw 2 proton pentate? CH2. If we are going to draw 2 proton pentate, I will put 2 hydrogen this side and 2 hydrogen this side. Now this will give you a 2 proton pentate. And if I'm talk about this one, this will give you 2 proton triplet. This will give you a 2 proton triplet only if the environment is same. So it means this is 2 proton triplet. This is also a 2 proton triplet. So it means this group is present in this compound. So the molecular formula is C3. So if it is C3 and H6, so C3H6 is occupied over here. Sorry. We just left 1 bromine and 1 Cl. If I'm going to put 1 Br this side and 1 Cl this side, so this is the structure of this unknown compound. Now, this CH2 and this CH2, they are different. Why they are different? Because this CH2 neighbor bromine. This CH2 neighbor chlorine. So both of these two CH2, they have different chemical shift, different ppm, because they are connected with different or electronegative atom. So this 2 proton will give you a 2 proton triplet, and its ppm is, its chemical shift will be in the range of 2 proton triplet is this one, roundabout appearing at 3.6 ppm. 3.6 ppm. While this is 2 proton triplet as well, it is appearing in the range of 3.1 around about 8 ppm. Now, why the CH2 next to chlorine is appearing at higher chemical shift? The simple reason is that because the electronegativity of chlorine is high as compared to bromine. Because the electronegativity of chlorine is high, so it will withdraw more electron density from this carbon from these hydrogen and making these hydrogen de-shielded. When the hydrogen are de-shielded, definitely they will appear at higher chemical shift. Okay, while this CH2 will give you a pentate, 2-proton pentate, and it is appearing in the range of 2.4 ppm. So this is the structure of this unknown compound. So let me write the structure again, and let me write the carbon 13 values. So CH2, 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 Br, and Cl. So this CH2 is this one, first one, going to appear round about, if it is 30, round about at 30 ppm. This one appearing round about 35 ppm, so 35 ppm would be this one. And it is appearing at 42 ppm, so 42 ppm is this one. So you have to write the structure like this. And what's the name of this compound? Numbering, how you will assign numbering to this compound, how you will write the IUPAC name of this compound. Numbering will start from here because bromo B come first as compared to chloro. So 1, 2, 3. So the name is 1-bromo 3-chloropropane will be the name of this compound. Okay, now let's look at the mass spectrum of this compound. If you look at the mass spectrum of this compound, CH2, 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 here is Cl, and here is Br. Okay, so chlorine and bromine both have 6 electrons, 3 lone pairs. So let me remove 1 lone pair from here. This one, this one, this one, this one, this one. Okay, so this molecular ion peak is going to appear in the range of 156, 158, and 160 because chlorine and bromine both will give you M+2 peak. Like bromine is present in the form of 2 isotope, bromine 79 and bromine 77. So 79 and 77 is this signal. While chlorine is present in the form of 35, chlorine 35 plus chlorine 37. Okay, now if I'm going to draw this signal 156 to 107, 156 to 107 means we have to lose 49. How I can lose 49 from this compound? So chlorine 35, carbon 12 plus 2. So if I'm going to remove this fragment from here completely, then we will get this fragment Br CH2 CH2 positive. So this fragment will appear at M over Z 107 or 109. Now, if I'm going to draw a fragment of 77 or 79, simply if I'm going to put this bond over here, then I will get Br positive, this signal. This signal is this one because bromine has 2 isotopes, bromine 77 and bromine 79, sorry. So bromine 79 is this. So now you can easily draw these fragments, Okay. So mass IR, we already talked about IR. IR spectrum is showing sp3ch, CBr, and CCl. So I hope you have enjoyed this discussion. See you in the next session. Wish you best of luck. Bye-bye.